Lithium-ion battery versus LifePO4 battery. Simple explanation. First, let's correct one thing. LifePO4 is also a lithium-ion battery, but in everyday market language, when people say lithium-ion, they usually mean chemistries like NMC, nickel, manganese, cobalt, NCA, nickel, cobalt, aluminum, or LCO, lithium, cobalt, oxide. When people say LifePO4, they mean lithium iron phosphate, also called LFP. So the real comparison is mostly NMC or NCA type lithium ion versus LifePO4 lithium battery. The chemistry in simple terms. A battery has materials inside it that store and release energy. In common lithium-ion batteries like NMC or NCA, the cathode uses metals like nickel, manganese, cobalt, or aluminum. These batteries store more energy in a smaller space, which is why they are common in phones, laptops, power banks, scooters, and some electric vehicles. Like PO4 uses iron and phosphate. It does not store as much energy in the same size, but it is more stable, safer, and usually lasts longer. A 2024 comparative study found that LFP batteries are safer, can exceed 2000 cycles, and can cost about 30% less than some similar lithium battery technologies. Let's look at the voltage difference. This is one major difference. A normal NMC NCA lithium ion cell is usually around 3.6 volts to 3.7 volts nominal and 4.2 volts when full and around 2.5 to 3 volts when low. For example, the Samsung INR series lithium-ion cells datasheet uses 4.2 volts charge voltage and 2.65 volts discharge cutoff voltage. A LifePO4 cell is usually around 3.2 volts nominal, 3.65 volts when full, and around 2.5 volts when low. For example, an EVE LifePO4 cell specification gives 3.2 volt nominal, 3.65 charge cutoff, and 2.5 volt discharge cutoff. 12 volts and 48 volt examples. For a 12 volt class battery, a nominal lithium-ion battery may use 3 cells in series. That's 3.7 volt times 3 equals to 11.1 volts nominal. 4.2 times 3 equals to 12.6 volts when full. A LifePO4 battery usually uses 4 cells in series. That's 3.2 volt times 4 equals to 12.8 volts nominal. 3.65 volt times 4 equals to 14.6 volts full. For a 48 volt class solar battery, LifePO4 commonly uses 16 cells in series. That's 3.2 volt times 16 equals to 51.2 volts nominal, and 3.65 volts times 16 equals to 58.4 volts full. That is why many 48 volt LifePO4 solar batteries are labeled 51.2 volts. Which one is more dangerous? The more dangerous one is usually the common high energy lithium ion type, especially the NMC, NCA, or LCO, because they store more energy in a smaller space and are more sensitive to heat, overcharging, physical damage, and poor chargers. LifePO4 is generally safer because its chemistry is more thermally stable. IRENA describes LFP batteries as praised for safety, durability, and cost effectiveness, while also noting that LFP has lower energy density than nickel-based chemistries. A building safety article also explains that thermal runaway onset for NMC can be around 150 degrees Celsius, while LFP is much higher, around 310 degrees Celsius, and that LFP releases less oxygen during failure, reducing fire probability. But please note, LifePO4 can still fail if abused. If you overcharge it, short-circuit it, use a bad BMS, use wrong cable size, or physically damage the battery, it can still become dangerous. Research on LFP thermal runaway confirms that LFP batteries are safer and long-lasting, but thermal runaway incidents can still occur, especially under abuse conditions. So the question on your mind is, can they explode? Yes, lithium batteries can explode in serious failure conditions, but it is not usually like fuel exploding immediately. The common danger is thermal runaway. Thermal runaway means the battery gets too hot, then the heat creates more heat, and the reaction becomes difficult to stop. The US Department of Energy's Energy Storage Safety Plan defines thermal runaway as an uncontrollable self-heating state that can be triggered by thermal damage, mechanical damage, internal or external short circuit, or electrochemical abuse. FSRI also reports that when lithium-ion batteries fail and go into thermal runaway, the gases released can create an explosion hazard if they accumulate. So the simple answer is NMC or NCA or LCO lithium-ion batteries are more likely to catch fire or explode under abuse than your LifePO4 batteries. In essence, LifePO4 is safer but not fireproof. So which one is better for solar? For solar energy storage, especially homes, shops, offices, and commercial systems, LifePO4 is usually the better recommendation. Why? It is safer, it lasts longer, it handles daily charge and discharge better, it is more stable in hot environments, and it is better suited for stationary solar storage. Normal NMC or NCA lithium-ion is better where size and weight are more important, like your smartphones, laptops, power banks, drones, scooters, and the electric vehicles. So the simple final answer, for solar, choose LifePO4 unless there is a special reason not to. But even with LifePO4, do not joke with correct charger settings, good BMS, proper cable size, correct breaker or fuse, good ventilation, no overcharging, no physical damage, and a trusted brand and warranty support. A good battery chemistry can still fail under bad handling and installation. Thanks for watching. I hope you find this video helpful. Do like, share, and subscribe.